Hi friends, in the program of Quality Improvement in Maths Education project, I, Ishwar Rayannawar from Gusli High School, Madhavnagar district Assembly, I am explaining the 3 steps for teaching a particular unit in the mathematics. I have taken the unit of mensuration for this. The first step of teaching is to observe and explore. This helps the students to create interest in the particular topic and to link the topic with their day-to-day experience. Now for this I have added one movie. Please observe this movie and discuss with you.
Circle or triangle has only one face or surface. These shapes can be drawn on a piece of paper and hence are not solids.
Here 2D shapes are converted into 3D shapes.
These shapes are referred to as two-dimensional or 2D shapes.
The 2D shapes have only 2 dimensions.
If we add one more dimension to each of these 2D shapes, then they are transformed to solid shapes. This additional dimension to 2D shapes is known as depth. These shapes have 3 dimensions and hence they are known as 3-dimensional or 3D shapes. Let's explore 3D shapes.
When the third dimension, in that particular video we have seen how the 2-dimensional figures are different from 3-dimensional figures. When the third dimension, that is the depth, is added to the 2-dimensional figures, it is get converted into 3D figures. Now with the help of this we should ask the students about the concepts of 2D and 3D. We should try say that to define 2D shape and 3D shape. And obviously we should ask them, is there any 1-dimensional figure? Yes, it will create some interest in them for observing all the figures around them and discuss the results, the answers given by them in their groups only. Afterwards, conclude with the correct answer. Now, from there we can easily call so many examples for plane figures and 3D figures. Plane figures we can get square, rectangle, trapezium, hexagon, like this, and 3D figures cube, cuboid, cylinder, cone, and etc. Now the topic, this is dealing with the use of formula to calculate perimeters, areas and volumes of plane shapes. This is the topic, the mensuration we are going to study. For this we should understand the concept plane. A plane is a flat surface that extends forever in all directions, that is the surface is unending. It is a 2-dimensional figure. 3 non-collinear points determine a plane. So far all of the geometry we have done in these lessons took place in a plane, that is the geometry related to 2D figures. But objects in the real world are the 3-dimensional. So we will have to leave the plane and talk about the objects like sphere, boxes, cones and cylinders. In the next standard we will deal with the 3-dimensional figures. Now the main part of this lesson comes under the unit define and prove. In this part we should give the theorems, the derivations of formulae, the concept clearance, and this will help the students to understand the particular lesson. Here I have given an example. Rajesh and Suresh have some line as shown in the figure. We should ask the students that, can you guess who has more line? Obviously there will be so many answers. Some will say Rajesh has more land, Suresh has more land, because by mere observation only we can determine the area occupied by the figure. For this we should say that formula is very necessary to find out the area. Now we will move to the concept area. The area is the space occupied by a closed figure. It is called as area. There are so many types of closed figures. Now let us revise some formulae we have learned in previous standards. Areas of geometrical shapes, 2D shapes. For the rectangle, we have area, length into width. For the square, the length and width are the same, therefore A into A, that is A square, that is side square. For the area of triangle, we have the formula 1/2 into base into height, and for the parallelogram, we have the formula base into height. Now, let us study very interestingly how we can derive the formula for area of triangle. We know the area of rectangle is base into height or the length into breadth. Here, this diagonal has cut this rectangle into two equal parts. Now, the triangle which is brown color, this will have area half of the area of this rectangle. That is equal to half of the area of rectangle, half into length into breadth. That is the half into base into height. This base and height is regarding the triangle. Now, if the triangle is not particularly right angle triangle, then how can we justify the formula 1/2 into base into height? It is quite interesting. Here I have taken again two rectangles for this support. This complete rectangle, in this rectangle I have the two parts. The first part is the part made by diagonal in this part, and the rectangle part 2 is get divided into two equal triangles. The first part of the rectangle is also got divided into two equal parts. Easily we can observe that the area of the triangle is equal to the area of half of the complete rectangle. That is equal to half of the base into height. Therefore, area of the triangle is equal to half base into height. This will help the students to understand the derivation of the formula of area of triangle. Now, one another quite interesting thing about the area of the circle. Here, the circle is get divided into number of sectors. If we arrange all these sectors in the particular manner, we can get a figure like rectangle. Here, the rectangle formula, area of rectangle, we know base into height or length into breadth. And here, the perimeter is one side of the rectangle and the radius is the height of the rectangle. Therefore, we can get area of this circle is equal to pi r into pi r square. Now, let's revise these two things again. The circle has its formula for area pi r square. The trapezium consists of one rectangle and a triangle. We can easily find its formula for area 1/2 a plus b into h. A is the side, longest side, which is parallel to the another side, the b, and the addition of two parallel sides into the height into 1/2 gives this area. Now, from the formula of area of circle, we can find the area of semicircle. The semicircle is 1/2 into pi r square. And likewise the perimeter, the semicircle perimeter comes pi r plus 2r. This 2r is the diameter of the semicircle. Now we use these various formulas for calculating our problems. Say some applications of mensuration. In our daily life we can use this formula for finding area of plot of land being bought or sold, the area of parking lot to be paved like this, or to make an ice cream cones and pencils, etc. For so many purposes we can use this formula. Now we'll check our understanding by solving some examples. Area of a triangle. Find the area of the following triangles. We know the formula of area of triangle 1/2 base into height. Now, in the first example, the area is equal to 1/2 base into height. Here base is 8 cm, height is 9 cm. 1/2 8 into 9, it comes 36 centimeter square as the unit of the area. For the second figure, we know from the diagram the base is 10 cm, the height is 12 cm. The area is equal to 1/2 into base 10 into height 12, that is equal to 60 cm square. In the third example, the base is 14 cm, height is 16 cm. 1/2 into 14 into 16, 112 cm square. Here, obtuse angle triangle is given. The base is 3.2 meter and the height is 4.5 meter. Here, the units meter is used. Therefore, in the answer, we should use the meter square for the area. Area is equal to 1/2 into base into height. The base is 3.2 meter, height 4.5 meter. It comes 7.2 meter square. In the last diagram, see the area. The area is equal to 1/2 base into height. The base is 7 millimeter. Height is 5 millimeter. Particularly, we should concentrate on the unit given. Therefore, the area will be in the millimeter square. 1/2 into 7 into 5, that is equal to 17.5 millimeter square. Now, let us use the formula for the area of trapezium. Area of trapezium is equal to 1/2 into the sum of the parallel sides into the perpendicular height. That is equal to 1/2 into a plus b into h. In this example, find the area of each trapezium. The parallel sides are of 12 cm and 8 cm and the perpendicular height is 9 cm. Therefore, area of this trapezium is equal to 1/2 into 8 plus 12 into 9. 8 plus 12 is 20. 1/2 into 20 into 9, that is equal to 90 cm square. In the second example, the perpendicular height is 6 cm. The parallel sides are of 5 cm and 7 cm. The area comes 1/2 into 5 plus 7 into 6. 5 plus 7, 12. That is 1/2 into 12 into 6. That is equal to 36 cm square. In the third figure, see the parallel sides are vertical and the perpendicular distance is horizontal. We should use the same formula here. The area is equal to 1/2 into addition of parallel sides 3.9 plus 7.1 into the perpendicular distance, that is equal to 5 cm. Here 3.9 plus 7.1 comes 11. Therefore, 1/2 into 11 into 5, that is equal to 27.5 cm square. Now, for revising the formula of area of circle, we have some examples. Here, first circle is of radius 8 cm. We know the formula for area of circle. It is equal to pi r square. Pi into r is 8, that is 8 square. We can take the value of pi 22 by 7. The calculation comes area is equal to 201.1 cm square. In the second figure, we have the radius of the circle 10 cm. Therefore, area of the circle, area is equal to pi r square. We will put the values of pi and r. Here the pi is 3.14 into r square, that is 10 square. The answer of area comes 314 cm square. Now, for more complications and more interest, creating interest, we can use all these shapes for creating a fun-like diagram. We can create the joker-like or cake-like figure, and we should ask our students to find out the area of the interesting figure. Here, I have drawn a toy-like shape. In this shape, the upper part is triangle, the middle part is rectangle, two semicircles, and a trapezium has been added for this example. The total area of the figure is the addition of all the areas of the figures included in this diagram. Therefore, when finding out the total area of given diagram, we should particularly find out the areas of different parts of the diagram and then we should add it. Here, area of triangle given, height is given, 1/2 base into height, that is 1/2 7 into 4. The area of a rectangle, here the length of the rectangle is 1 plus 5 plus 1, that is equal to 7 centimeter, and the breadth of the rectangle is 6 centimeter. That is length into breadth, that is equal to 7 into 6. The area of these two semicircles, that is equal to 1/2 pi r square. The r value is half of the height of this rectangle. This is the diameter for this semicircle. The radius will be half of 6, that is equal to 3 centimeter. If we put the value of r is equal to 3 centimeter in 1/2 pi r square, we will easily find the area of particular semicircle, and these two semicircles are common, therefore we can double it simply to find total area of these two semicircles. And in the case of trapezium, we know the sides parallel to each other, they are 5 cm and 6 cm respectively, and the perpendicular distance between these two parallel sides is 2 cm. Therefore, by putting the values in the formula, we can find out the areas of total parts of the figure, and by adding these areas, we will have the total area of the figure. Friends, the topic has been divided into 3 parts: observe and explore. In this part, we should create interest among the students about the particular topic. We can use some charts, we can use some figures, some videos, or a story also, or a song also. This will help the students to concentrate in the particular lesson. And the second part, define and prove. We should explain the theorems, the formulae, or the content part of the lesson. For this, we should adopt the technique of discussion among the students. The discussion will help them to improve their knowledge by themselves, and it will be very useful for the recitation or for the understanding of the given concept. And the third and the last part is the apply and evaluate. We should give such questions to the students that they should relate with their daily life, or they should be interesting one. This will help students to understand the topic particularly and to apply the mathematics in their daily life. The ultimate aim of the mathematics is to make the daily life very easier. I hope you might have understood these 3 steps in the mensuration. Okay, thank you.